Alright, hello, good afternoon everyone. Welcome to today's Sec 4E math lesson with me today, teacher Jason over here. So let's get started for today with our lesson ahead. As such, going to the clock, let's go. Alright, so general rules: just be patient and understanding, observe gracious and respectful behavior even in digital space. Lastly, if you have any good and relevant questions for today, feel free to type. Alright, don't be shy and just make sure you ask ahead. Any queries, just ask ahead. I'll be more than happy to answer. In the lesson, if I can answer fast enough, we're doing this 1 hour, or if not after. Alright, okay, so let's get started. Again, further revision. So today, what are we going to revise further for this geometry and measurement section? We are actually going to look at measuration, so all your different shapes, different whether 2D or 3D, looking at perimeter or volume, or in this case, looking specifically towards arc length, sector area, and see what other questions that can come about from there. But before that, let's get on to our revision first. Alright, so let's get on to our revision first at a start over here. So let's start on by revising certain things over here: area and perimeter on plane figures. So first up, for triangles, okay, how do we find the perimeter of a triangle? Okay, over here, just to revise, it's to just none other than sum of my sides. Okay, so the perimeter of a triangle is to just sum of my sides. And while I'm writing this, does anybody recall the area of a triangle if you were to type it out? What is the area of my triangle? Alright, this is learned in Sec 1. It should be ingrained in you now. So assuming I have a base and a perpendicular height, besides using trigonometry, how can I find the area of a triangle? Alright, okay, so very good here. Let me give a hint. I have a half over here times, alright, very good. I see some replies over here, times base times height. Half times base times height. That's going to be my area over here. Following up next, I have my squares over here, L. Yes, Pranav, you can use that as well, A, B, sine, C, but that is assume you don't know the angle. Alright, if you have a right angle, ideally what we can do is half times perpendicular base times height. But that's a good start. That means you know your trigo well. Next up, for my squares, okay, squares, we know each of the sides are equal. In this case, perimeter, just summing 4 of them, or we know it's 4 times L. Area, in this case, 2 of my sides is just taking them and then I square. Rectangle, okay, it's just a different version of a square. I pull it out, okay, so it's going to be actually be 2 times my length plus 2 times my breadth. And in this case over here, what happens, area is just length times breadth. That is my area over here. Okay, so these are the shapes we should be familiar from primary school, I would say. And moving on to what you have actually learned in Sec 1, parallelogram. Just like our triangle, for our parallelogram, we just sum the sides. Okay, there's no special way to find the perimeter. We just sum the sides of my parallelogram. Sum of the sides of, in this case, my parallelogram. Now in this case, for my area, does anybody wants to give it a try? How do I find the area of my parallelogram? I'll give you a few seconds to think about it. Recap all your concepts back. How do I find the area of a parallelogram given that I know one of the sides and the perpendicular height? Okay, what is the area? Okay, I'll give you a while to think about it. Alright, very good. I have perpendicular base B times H. Very nice. I see some of y'all make sure you know the concepts already. Very good over here. Moving down to my next shape, I have my rhombus. Okay, rhombus over here. What do we do over here? It's going to be summing, because all my sides, we call rhombus, all my sides are the same. 1, 2, 3, 4. Each of them are B, so it's just going to be 4 times B. And in fact, area over here for the rhombus is going to be same thing as a parallelogram. Very good, Pranav, P times H. Okay, lastly, over here, perimeter for a trapezium. Similarly, nothing special. Perimeter is just summing the required sides that you need to know. Okay, summing the sides of, in this case, my trapezium. And for the area over here, it follows a very peculiar way. If I want to find the area of a trapezium, does anybody recap over here? How do I find the area of my trapezium? Okay, area of my trapezium. If you have to recall, we have to actually sum two things over here. Okay, almost there, Pranav, but it's not 1/3. Okay, there's no 1/3. 1/3, I think you are confused with the volume of a pyramid. So in this case, we are looking at actually 1/3, half, times sum of my parallel sides times h. Alright, so you have to take note, this is for the trapezium. Maybe a typo, but just be careful. Alright, but now moving on over here, moving on to our next two familiar shapes. Circles, semicircles, and quarter circle. Now, why one row for quarter circle specifically? You realize it may not be a shape, but what happens over here, it is because there might be a particular case whereby it consists of just quarter circles, usually combining different shapes together. When your composite shapes consist of quarter circles, a square, it is possible. So it is quite ideal to be familiar with these three shapes over here. First up, perimeter. Perimeter of a circle, I hope you all realize, is 2 pi r. Area of a circle, pi r squared. Next up, moving on to semicircle. Does anybody want to try? Is my perimeter of my semicircle just pi r, since it's half of it? Is it just pi r if I look at the whole semicircle? Is it just pi r? Okay, very good, Pranav. Okay, for the rest, I hope you all realize you only actually just need to. Very good. Okay, Denise, that is correct, but you have only found for the first part. You actually need to add something, because what you have done, you have only add for the first part. You actually have to add something over here, which is the length over here. Very good, Denise, that's actually correct. Okay, now take note over here, there's actually a misconception. This part is actually usually forgotten. Alright, very good, Pranav. Okay, you've gotten it from my quarter circle respectively. Okay, but let me just backtrack for everyone to see. This is usually forgotten, so you actually have to take note my plus 2r, which is actually this part over here. So just take note. Okay, and over here, area of my circle is semicircle is half of it. Okay, this one is okay because it's just the area, the region, it's cut by half. Just like my face over here is cut by half. Lastly, for quarter circle, okay, Pranav following up very nicely, it's going to be actually half pi r plus 2r, because again my circumference of the circle is cut into 4 parts, given here as such. And what happens over here? Area is going to get cut into half again, which is then 1/4 pi r squared. So the area over here is not really of an issue, is you have to take note for my quarter circle with my 2r, if my whole circle is given. So very important to take note over here. Now, we have done with plane figures. Let's move on one notch up to my 3D figures. So not everything is in 2D. Unfortunately, you have 3D following up. And when it comes to 3D, two things you have to take note. Two things. One is the surface area, two is the volume. Very good, Denise, following up nicely. Surface area is actually just 6L squared. And what about my volume for a cube? Cube, remember, it's just all sides are equal. For my volume, very good, base area times height. In this case, base area is L squared, height is L. So in this case, volume is just L cube. Following up to my cuboid, in this case, it's just rectangular faces. At the bottom here, at my side over here, and at this side over here. So looking at it, each of them has 2 parts, so it's going to be just none other than 2 of LB plus 2 of BH plus 2 of LH. That's the notion over there. And therefore, volume is just base area times height again, which is my base area is L times B. My height is H over here. That is the notion. Okay, following up, more shapes to come. Okay, just bear with me because you have quite some shapes. We are covering for every shape I've learned from Sec 1 to now, so just bear with me. Okay, so from what we have done so far, following up cubes and cuboids, the next shape we are going to focus on, it's cylinder and cones. Now for cylinder, surface area, does anybody wants to recall? In this case, following up. If you understand what is the notion for the surface area, this shouldn't be an issue. So I'll give you a few seconds to type it up. Okay, that's for, you are missing one thing for the curved surface area. Okay, Very good, Denise. That's actually the whole thing over here. Very good. For now, if you're missing actually something, let me just write it out for you. 2 pi r, you are missing the square because you have two circles. Okay? Plus 2 pi r h, you are forgetting the height. Yes. So just take note. Okay? Don't worry about it. We all learn together. And as well as keep a positive mindset. Be open to what we are learning together. Okay? Next one, volume. We have our base area, which is a circle, pi r square, and the h. We call the radius is r, height is h. Following up nicely, we have a cone. Now, does anybody recall the surface area of a cone? Okay, first up, we do have our circle. But how do we find the curved surface area of a cone? Pi r square plus. Okay, there is a reason why this specific letter is here. Pi r. Very good. Very good, Denise. Following up nicely, I have pi rl. Following up nicely. Very good. And henceforth, my volume is actually 1/3 of a cylinder. Okay. It's following up nicely. 1/3 of a cylinder. Base area times height. Perfect over there. So the base area in this case is a circle. Height is just the height of the image over there. Alright. Now, following up further from there. Okay. I think this is the last two before we head to our, no, there's still more. Okay, there's still more shapes, so just bear with me. 4 more shapes, this is 2 of them. Prism. So recall what is a prism. A prism is a shape whereby I have a uniform cross section. So if it's a uniform cross section, that means if I were to cut it even through here, you are going to get a shape that is over here as well. Okay, so that's the uniform cross section. Okay, let me just draw it a bit nicely so that everyone can see. So if I were to cut it here, you are still going to get a shape that is over here. Okay, so what does this mean? This one just means, if you were to recall in what we have learned in Sec 1, it follows this particular formula. Okay, that is for this shape over here. Very good. But in general, how do we actually find for all prisms? Okay, we have to actually find the area for 2 of the bases, regardless whether it's, in this case, it's a triangle, but in general, it can be a square, a parallelogram, a trapezium, what I've learned so far. And what we do, okay, for the curved surface area over here, for the white color regions, so in this case over here, we can find by, in this case, the perimeter of the base, in this case is my triangle, multiply by my height. Okay, this is what we have touched on in Sec 1. If you want to understand the derivation to why, you can recall and revert to the recording for the perimeters and areas of plane figures. Okay, it will actually explain to you why the formula is as such, not only for triangles, but for the rest as well. Volume is going to be area of, in this case, the base times the height. Again, I'm writing triangle because it shows a triangle here, but in general, we know it's for any base, as long as it's uniform throughout. Now, next one, pyramid over here. This one is just none other than summing the curved sides depending on what the pyramid size is. So it's going to be area of the triangle sides plus, in this case, depending on what base with you. Again, it can be a parallelogram, it can be a trapezium, but ultimately it will all curve in. So it's going to be area of the base. And for pyramid, it's a little bit special. It's not just base area times height. Okay, this is 1/3. You have to consider 1/3 of it. So 1/3 times base area times height. Very important note over here. Okay, very important note. All sides, yes. For pyramid, all sides of the area. Will all sides have the same area? It depends on the pyramid form. Alright? But in this case, a pyramid is just ensuring that we can cut it throughout. And it's not even. It's not like a prism where we cut it, we have the same cross section. Alright? All sides may not have the same area. Okay, it depends on how the pyramid is formed as such. Okay, Dennis? Now, next up, following up nicely, we have our sphere and hemisphere. So sphere, surface area, it's going to be 4 pi r squared. Derivation, you don't have to know. Volume is 4/3 pi r cubed. Give me a while, Pranav. I'm almost done. Hemisphere is going to be, take note, it's not 2 pi r squared, it's 3 pi r squared, because it consists of the big curved surface area and my base. Okay, the base is the one I have shaded over here. And next one, but the volume I can say is 2/3 pi r cubed. Alright, so these are the things we can take note over here for spheres and hemispheres, and for Pranav as well, prisms and pyramids. Alright, once we are done, we are finally going to go to the first few bubble questions that you will face for such. Okay, alright, seems like you're ready, and let's proceed on. First bubble question for today. I have such an image. How would I have such a figure? How would I find my plane figure? Alright, launching my bubble launcher in 3, 2, 1, let's go. Alright, let's see how we fare over here. I hope timer. Alright, very good. I do have my first response already. Good job. For the rest, give it a try. Try to understand how do we find this particular area. Okay, take note, what are the shapes forming this shaded region and how do we form from there? Alright, just make sure that you guys, when you attempt this question, always make sure that don't force yourself, don't beat yourself too hard if you cannot do it. Always have a positive mindset to what you ought to do. Alright, very important. Okay, we have about 1 minute and 40 seconds left. Alright, just hang in there with me. For those who are still doing, you have some time. Don't fall into my trap, alright? Very, very important. One minute, 20 seconds. So once you know the shapes, you realize that you can form my shaded region very easily. One minute left. Okay, for those who have yet to key in your response, please do so quickly. Last 30 seconds. Alright, responses are going not too bad. 30 seconds. Last 20. Hang in there with me. Last 5 seconds. Alright, doing good. Last one, just nice. Okay, let me take a look at the response. Okay, not too bad. Most of you got it, but I think some of you have hard time identifying the shape. So let's see from here. So finding the area of the shaded regions, there are actually two types. One, you add different figures together and we try to solve. Two, we might have one very big figure and certain things are actually subtracted from it. That means I cut them out. So if we can look at it a few ways, is it possible that we add familiar figures over here? In this case, not really, because there isn't a figure of a shape that is just this and this together. It's hard to see. So what we can do, you realize if I take a big look at this as my first big trapezium over here. So my first trapezium over here is going to be, say, A, B, C, F. Okay, ABCF, recall your sides, it's going to be half times my parallel sides, 24 plus 84, because 48 plus 36 is 84, times my height, which is BC. This is going to give you my trapezium 2592 cm squared. Next one, parallelogram. Parallelogram, in this case, is identified over here. Okay, some of y'all may say, okay, where is my trapezium? A, B, C, F. Next one, if you realize I just subtract these two things over here. Parallelogram, next one, D, F, G, H. This is equals to, what is my base over here? 48 times 24. 48 times 24. It is not mentioned over here. So we try not to assume. Alright? If the image, okay, one thing to take note, if the question did not mention whether it's a midpoint or anything, or it did not mention something like this. Very good note over here, Denise. It did not do this. I cannot assume it's the midpoint. Okay? Unless anywhere in the diagram or in the description specify that it's a midpoint, we cannot do this. You use this to find GH. You do not need to do this because GH is equals to DF. So essentially, this is my perpendicular, this is the height over here. But I hope I answered your question. Okay, next one, okay, let me just follow on first. 48 times 24 is 1152 cm squared. That's my parallelogram. Next up, what's another shape to find? Semicircle. Semicircle, we know is 24. 24, we divide by 2 because we want to find the area. So half times pi times r squared. R is 12 squared. Move on, 72 pi. We have all the shapes ready. So what we do? We subtract them. That's the main notion over here. We subtract them. So my shaded area is just the big shape minus the small shapes. So 2592 minus 1152 minus 72 pi. Take your calculator, press it, don't mental sum. I can't mental sum as well. 1213.80532. Round out to 3SF, 1210 cm square. Okay, and we do 3SF. Remember, all your answers are in 3SF, and henceforth, this is what I have. Alright, okay. Anyway, for Denise, do you understand my explanation? Okay, because we cannot just take the midpoint as we cannot assume. GH, because it's just the sides are parallel, so this is just GH. There's no need for cutting. Okay, I hope you have understand. Yes, if not, we can clarify in the Q&A later. Alright. Next one, bubble question 2. Now over here for the next few bubble questions, 2, 3, and 4, they 2, 3, 4, and 5. They are actually related to each other. So let's see how we answer them. Alright. Bubble question number 2. Launching the bubble launcher in 3, 2, 1. Let's go. You have about 2 minutes, so give yourself some try to read about it. We can assume it's a parallelogram actually because my DHGF is a parallelogram. It's not a closed figure part of a parting, back to bubble question 1. It's not a closed figure to be part of the blue color one, but it is actually a parallelogram by itself because by definition, parallelogram has 2 parallel sides. So we can actually just take the opposite sides of parallelogram. GH parallel to DF, GF parallel to DH, if you recall the image. So that's why I can say that both sides are parallelograms. Okay, but then again, let's find this part A first. It's going to take a while, and I do have some responses. Alright, total surface area of the solid. Please take note what do you need to find. Alright. Okay, I'm finding the total surface area. So take note what do you need to find over here. Don't fall into the trap. Okay? If you use what is given, definitely you have enough time. You have about 5 more seconds. Okay, I think most of you all got it. For those who did not, let's see where went wrong. All right, let's see where went wrong. Okay, let me check the responses. Okay, so total surface area of the solid, you do have to understand the surface area of the solid is which part. Okay, very important. In this case, it's just consisting the curved surface area of the cone, curved surface area of the cylinder, and only one circle. This part is not the surface area because it is covered by the cone already. So it is not on the surface because on the surface you can't see this part. Okay, so how do we find it? First up, we have to find the curved surface area of the cone. So the curved surface area of the cone. Okay, we call curved surface area of the cone is just going to be pi times, what is r? R is half. So 5.4 of, which is half of this, not of, sorry, which is half of this, times my curve height. Curve length, sorry, 7.4, which is 39.96 pi. Just leave it as such first. Now we need to find the next part, which is the cylinder. So for the cylinder, take note, we don't find the whole cylinder. We are not finding the whole cylinder. We are just finding the curved part of the cylinder, which is 2 pi r 5.4, h 4.7, and then we add the base of the cylinder, pi times 5.4 squared. Following up nicely, we are going to have the numbers here, or these are just numbers. I'm leaving them in terms of pi for the greatest accuracy first, because we call in your workings, we want to have the highest accuracy, as much accuracy as we can. 29.16 pi, this is equals to 79.92 pi. Lastly, add these two up. And that's where we have my total surface area to be equals to, just add these two up, 79.92 plus 39.96, include my pi as well, do not exclude my pi. Okay, this is equals to 119.88 pi. Okay, following up further, this is just writing out, take your calculator, press 37.661412. Again, I want my answer in 3SF. So 3SF, write it out, 377. Write your units in your answer as well, and write to 3SF. Okay, over there, if you were to look at my answer over here, to 3SF. So that's where my answer is over here. Okay, so just take note of the curved surface area, because some of your mistakes you have made. One, you use the diameter when you find the curved surface area of the cone or the cylinder. Two, in this case, when you find the curved surface area, use the perpendicular height instead by using Pythagoras theorem, working too far out. So just be careful, remember your formula as well. Okay, now, next one, bubble question number 3. Find the volume, okay? Volume should be alright, okay? But let's see how we fare. Volume. Launching the bubble launcher in 3, 2, 1. Let's go. Alright, let's go. Okay, volume over here. In this case, volume, what do we need to use? You have about 1 minute and 10 seconds left. So take note, what do we need to use now? Very important. Okay, we need a little bit extra steps to do this, okay? So just take note what we actually need to do here. Alright, okay, seems like the responses here are better. Hang there with me, you have about 40 seconds left. Hang there with me, alright? Regardless where you are, you guys are doing awesome, but any questions you need, just let me know, alright? Very important. Alright, I think it seems like this question you guys are acing it very well. You have about 20 seconds left. You have about 10 seconds left. Last 5, 4, 3, 2. Alright, I think most of you got it. This one is not of an issue, but let's see for those who have gotten it wrong, don't worry about it. I'll still go through, but good job to everyone else, regardless wrong or correct. We're all learning together. So if you realize over here, we need to find something. Volume for the one at the bottom, it's okay. I think most of you got it. It's the one at the top because we are missing something over here, which is our perpendicular height. And how do we find it? We know it's right angle, so whenever right angle triangle comes into mind, your very famous mathematician should come up for you by Pythagoras theorem. Okay, this is the first mathematician that should come to your mind, and it will continue to haunt to you all the way. Okay, not haunt you, it will continue to stick to you. Okay, haunt is not really a good word. Okay, so I have h. H over here, we know in this case, follow Pythagoras theorem, is the square root of 7.4 square minus 5.4 square. This is equals to, okay, square root of 25.6. Following up, evaluate 50596. Once you have the height, volume, quite straightforward. I have the volume of my solid. So the volume is none other than, first up, volume of cone. Don't take half, 1/3. 1/3 pi, what is R? R is 5.4. Okay, so 5.4 square. What is my height? We just found just now. It's going to be 50596. That is my volume. Next up, how do I add my cylinder? Cylinder is going to be none other than pi. We call what is my radius in this case, times 5.4 square. What is my height? Height is 4.7 square. Add them up, take your calculator, press it. You are going to get the values of 585.06427, 3SF. I almost point the wrong thing. 3SF, okay? 585 meters cubed. Remember your units well? 2 3SF. Alright, so that's where we get the answer over here. So just track, know all the shapes that you need to find, and we solve from there. Okay, now following up nicely, bubble question number 4. Okay, so this is another kind of question whereby we actually need to melt to a new sphere. Okay, so of course we need to know the new sphere first. Okay, the solid is then melted to form a new sphere. Okay, previous volume we know it's 585.06427. Alright, melting to this new sphere. How do we solve it? Launching my bubble launcher. Don't worry, Pranav, I've written it already. I'm not expecting you to memorize, don't worry. In 3, 2, 1, let's go. Okay, so this is the volume of this solid. I'm just melting it to a sphere. Alright, okay, you guys are doing well, doing good. Okay, so I hope to digress out a bit, I hope you guys are okay, doing good with all the revisions so far. I hope all the Genie classes have been helpful. Okay, if you have any queries, alright, feel free to ask me in the Q&A sessions, because I realize this batch is quite a shy batch. Alright, so just feel free to ask anything. Alright, don't be shy. Okay, I'll be more than happy to answer any of your queries. Okay, very important. Okay, very, very important. Now we have a little bit more than 40 seconds left. Alright, so we can just try to see how much we can solve from there. Okay, we have 30 seconds. $20 seconds left, and you guys are doing good, hanging there with me. Last 10 seconds. Last 5. Last 3. Alright, let's take a look. Okay, most of you all got it, but let's see how we solve this for those who are unable to identify. Or in fact, you might have gotten the formula, not too much. Okay, so what happens? This is my solid. I'm just melting it and making it form another shape. So a solid sphere. So from this shape to another shape. Volume, will my volume change? I'm just melting it, right? So does my volume change? This one will not change at all because I'm just melting it and forming it to another solid. So I can reuse the volume, and in this case, that's why it's written there, and use the volume for a sphere. 4 over 3 pi, finding the radius, r cube. I almost said square. For those who use r square, you might got this answer, so take note it's r cube, which is equals to my volume, and that is where we just need to maneuver from there. Okay, from there we take r cube. Okay, for those who type your calculator wrongly and divide by multiply by 4 and divide by 3 instead. Okay, take note. Okay, be careful when you key in your calculator, especially if you key in different steps. Okay, r cube. You can try again. You should get this value 139.67380. Write as much significant figures as you can. 5 decimal places if possible to ensure that the answers do not change along the way. From here, we actually cube root, don't square root, cube root. Okay, and we do the cube root of this to get my value here, 518845. 3SF 5.19 meters. That's where we have. For those who want to find other notions over here, just take note. Be very careful. That's where we have 5.9. Okay, so just make sure what are the certain things that happens when, in this case, melt and recast. What happens? Very nice notion over here. All right, thank you, Denise. All right, that's a very nice compliment over here. Next up. 80 of these spheres need to form and need to paint. So given that a liter of paint contains this, find the number of paints required. Okay, for this, of course, I am not saying anything. You will need the previous part. So we call the big sphere. Is there an error? Let's go back. There is... Where is the error? Okay, let me take a look. All right, okay, I will change the values for you. Thank you for noticing for me. Okay, so let me write first. Okay, don't panic, do not panic. All right, okay. Yes, I just realized also. Thank you for the high note. So 518845. All right, do not panic. I am going to write the actual values now. So from here, all right, take note. This is the value of the big sphere. Don't worry, I'm gonna change them now to the values or options given to you. So don't panic, alright? Thank you for your sharp eye. Thank you for the sharp eye. Okay, so I am going to have these values over here. So first one, let me just change to what I have. Second one. Third one. Sorry. 2, 2, 5. Okay, so my options are now the green, red color ones, alright? So take note. Last one. Okay, these are the better options now. I was almost about to lunch, so just take note for me. Thank you so much for the sharp eye, Isabel. And yeah, thank you for the sharp eye, Isabel. Okay, so yes, we can work from there. And take note, this is the radius of these big spheres. Wait, no. Radius of the sphere, I don't have a big sphere. This is just for the sphere itself. I just need this sphere. Radius of this sphere itself. How would I solve for the rest? Okay, how would I solve for the rest? Alright, launching the bubble launcher in 3, 2, 1. Let's go. Okay, so for this sphere, alright, just double check that you know what is received over here. Let me just see. Okay, yes, can. All right, very good. All right, seems like everyone is doing well. Okay, so for this one, it's an add-on question. It's not really for geometry, really. It's what for a very common type of questions whereby they put a rate over there. In this case, what is the rate given? I hope you all realize a liter for every 12 meter square, and how we find what is required in the question. Okay, we have the last 40 seconds. All right, very good. Last 25 seconds. Last 18 seconds. Last 10. Last 3. All right, time is up. Let me take a look, and yes, most of you did it well. Okay, so for those who did not, let's just take a look. Okay, so what we are doing over here, take note, you have to know your formula of a sphere well first. Since we are finding the area, it's going to be the surface area of the sphere we are looking at. So surface area of my big sphere, surface area of my sphere, recall, it's going to be 4 pi r squared, so 5.18845 squared. Following up nicely is going to be 338.28686. That's the surface area of the sphere. How many spheres do I have? Look at the question. I'm painting every one of them. So it's going to be my total surface area. I have 80 of them. So I need 80 times my surface area required for the spheres. 80 times it. Okay, you're going to get a value of 27,062.9488 total surface area. That's what I have. Lastly, paint. 1 liter is 12 meters squared. I have this amount. How many liters do I need? So the amount of paint I have is none other than this surface area of the sphere I need to cover divided by the amount of paint. Again, 2455. So some of you actually round down. You may say, teacher, your answer is incorrect. Why do we round down? Regardless of what happens, we need to round up. If we round down, we don't have enough paint to cover the next one. So for this one, we need to round up. Okay, make sense of the question. Not everything because, oh, less than 5, so we round down. We have to make sense of the options or the questions there. Okay, because to cover every paint, a bit of extra is okay. So to cover every sphere, we need to round up. So this is a particular thing that we need to take note in order to ensure that our answer makes sense. Okay, so these are the bubble questions you have been attempting well so far, guys. Good job. Now let's move on to the next few parts over here. For my arc length and my sector area. Alright, conversion between radians and degrees. Come, does anybody remember? Pi radian, how many degrees is it? What is that magic number I'm looking for? Okay, pi radian, how many degrees is it? Okay, it starts with 1. Sorry for that. Pi radian is how many degrees? Alright, very good. Pi radian, I think some of you know already. It is, take note Pranav, that's not correct. That is 2 pi. So I actually just need to, very good, 180 degrees. So once you have this, or pi radian, 180 degrees, that is your basic unit of conversion to convert between radians and degrees. Once you have that, following up nicely, arc length is just finding a segment or a part of the circumference of the circle. So what we are doing here, given the circumference of the circle, we are finding a section of the circle. This is x. Degree, a section. Sector area, given a circle, we are finding a section of the circle. That is what we have. Following up with that, if we have degrees, we have for radians as well. Radians, okay, if we were to do the conversion, let me just break it up. Given the section of a circle, almost there, Pranav, it's not 2r, almost there, we are finding a section of the circle, which is r theta. That's right, good job, Denise. Pranav, just take note, the 2r is not just 2 of my radius. And following sector area, given the area of the circle, okay, but go try, Pranav, okay, we are finding a section of the circle. 2 pi is 360, cancel it out. I have half r squared theta. So you have to be very careful whether the angles are given in radians or degrees, because your formula will matter from there. And with that, we have the next few 4 bubble questions. Wait, no, is it 4? Sorry, we have the next few bubble questions that relates to that, and we have bubble question 6 and 7 relating to the question. Alright, so just take note. Over here, bubble question 6. Look at the question carefully and see how it goes by. Launching the bubble launcher in 3, 2, 1. Let's go. Alright, look carefully. I'm finding the arc of VT. Alright, so what is the arc of VT? Alright, this one requires some thinking, so take a look very carefully over here. A lot of information. What is required? So to find the arc of VT, what is it? This is my arc. Okay, so what do we need to find? 1 minute and 20 seconds left. Alright, I'm seeing all the answers coming up. Okay, let's take a look. Alright, 40 seconds left. For those who have yet to key in your answer, please key in accordingly. Responses are going good. Okay, seems like there's a little bit by half over here. Take note. Okay, some of you are falling into the trap over here. Is it really just multiplying it by 5? Take note, arc of VT. Look at the diagram carefully. Last 10 seconds. Last 3, 2, 1. Alright, let's take a look. Okay, I would say most of this question a little bit tricky, because some of you thought, oh, arc of VT. So what happens? Oh, this is 5 cm. So this must be 5, and then I do r theta. But take a close look. Is that really 5 cm? Is this really 5 cm? And so is this really 5 cm? If I take a close look, okay, in order to find VT, we have to actually use, in this case, either this one or this one over here. But both of them, you realize, this one over here is either this or this, both have to be the same. Take note, center S. So SV has to be equals to ST. But take note, this is definitely longer than 5 cm. So we cannot use 5 cm instead, and we have to find a new way. Now, if we look even further down, radius 5 cm for my semicircle SUV. SUV. This is my whole semicircle. Looking at that, radius 5 cm. If this is 5 with center O, OS is 5, what can we say? This is 5 as well. And in order to find the length of arc, take note, you have to have two things. One, the angle. Two, the required length of the arc, or the radius to find the arc, to be more correct. So to find this, you realize first that we can use tangent. That's where our trigonometry comes in. Tuokaso, opposite, adjacent. That's what you have, because this is the angle spanning the arc over here. So tangent of, in this case, very good, Pranav. That's actually 45, because OSV, opposite over adjacent, I have it to be 45 degrees. Now from there, what can we do? Or how do we find 45 degrees? I hope you realize is tangent inverse of 1. You can use your calculator. It will give you 45 degrees. Now from there, how do? We actually need to find out this length over here. This is not 5, right angle triangle. Again, we can use our Pythagoras theorem. So by Pythagoras theorem. Okay, it's just very good. Wow, you guys are doing very quickly. Square root 50. How do I get square root 50? Very good, Ian. Thank you. SV is square root of 5 squared plus 5 squared. We get square root of 50. Okay, lastly, that's where we use the arc formula. I have arc for VT, alright? It's again the proportion, which is 45 degrees over 360 degrees multiplied by 2 pi r. And that is where we get the answer, 5.55. Again, when you write your working, always write in my decimals first, as long as you can. Preferably 5 decimal places, if possible, before we actually round up to 3SF, 5.55 cm, and therefore my answer is at number 4. Okay, so backtrack to where you need to do. To find the arc, look at the question, center S, so this is equals to this, but this is not 5 cm. How do I find from there? Yep, area will be pi r squared. Area will be pi r squared. Yep, that's right, if they were to ask you to find the area. Okay, if not, what happened? Yes, if they were to ask you to find the area. Okay, very important. Following up with your query, that's where you might have to use pi r squared. Alright, there's a hint over there. Launching the bubble launcher in 3, 2, 1. Let's go. That's where I have to use pi r squared. Okay, so apologies for that. I think it will be better to give you the radius. So to backtrack, r is 50. For, in this case, the r over here I'm talking about is the one with the arc. Okay, I apologize again. The one with the arc. So that's where it'll be better. Okay, once you have this, you realize you can do it as such. Alright, seems like you guys are doing good. Hanging there with me. Right, 1 minute left. 1 minute left over here. So take note, in this case, based on the things that you have there, what do we have over here? How do we solve this? How do we get this area of shaded region? Last 40 seconds. Alright, last 20 seconds. Okay, it seems like this question is going well. Hang in there with me. Last 3. Alright, let me take a look. Okay, be very, very careful over here. Take note, what are we finding? Okay, what are we finding? First one over here, okay, we have to find the area of shaded region. So I hope you realize we have to find the big sector first. That's the hint over there. Sector TSV. This is where you use pi r squared. 45 degrees multiplied over 360 times pi of 50 squared, giving this value of 19.63495. Now some of you actually went and actually just went and find me the triangle. That's very good, but that's not the shaded area. Okay, it's actually half times base times height, half times 5 times 5. Or if you want to be atas, you can actually use sine 90 degrees, AB sine C, but that's not needed, okay, because you still get 12.5. Okay, that's the majority of the options. Take note. Lastly, shaded area. Shaded area, I hope you realize, is this big sector over here that we found, TSV, okay, which is equals to 19.63495 minus 12.5. Okay, sector, we call this is my area. This is the triangle area over here. Subtracting them, I get 7.13495. 3SF, 71.3 cm squared. Again to 3SF. First one, before working, just make sure you write it as much decimal places, 5 decimal places if possible. After that, I write it in 3SF. Okay, so take note what you need to find. In this case, we need to subtract. Alright. Very good note over here. Seems like from the responses is good, but for those who answer very wrong, I hope you understand where you went wrong. Alright, 2 more bubble questions to go. Bubble question 8, another new question. Okay, I might exceed the lesson a little bit, so just bear with me. Launching the bubble launcher in 3, 2, 1, let's go. Okay, perimeter. I'm looking for the perimeter. Look at the question carefully. Which is my 3 cm, which is my 7 cm, and how do we solve? Which is my 3, which is my 7, how do we solve? Alright, very good. Perfect over there. If you know which is my 3, which is my 7, this will be alright. Okay, about 40 seconds left. I'm seeing the response is going well. Very good. Okay, so again, if I'm not really able to see this clearly, radii 3. Okay, so we can draw it out. Radii 3, so this is 3. 7. We can say 7 over here. Both are the same. But we can draw it out this way and it will be easier. Last 10 seconds. Just bear with me. Last 5, 4, 3, 2, 1. Alright, very good responses I have over here. Good job. Give yourself a pat on the back. Okay, this is where a question requires you to be meticulous in terms of finding what is required. Perimeter of a sphere. How would I do it? So to take note, my perimeter of the cloth section, I only want the cloth, PQRS. Okay, so I'm looking for this one. So you actually have to just sum this one, these two which are the same, this arc and this arc. And to find the arc formula, because my angle is not given in radians, so formula becomes much simpler. First one, I find SR. SR is the big arc, R theta. R theta, so it's 7 times 2.5. This gives me 17.5. Next one, arc of the smaller one, which is PQ. 3 times 2.5. Alright, this is equals to 7.5. Lastly, perimeter. How do we find it? Perimeter equals to the big arc SR, this one over here, plus the small arc PQ, this one over here, plus summing the two, this one and this one. So which is 4 and 4, because 7 minus 3. That's how you give the 4. And this gives me my perimeter of 33 cm, which is why my answer is number 3. So take note over there. Alright. Now, my last bubble question for today. I want the area. So how would I find the area? Okay, last one, give it our best shot. Launching the bubble launcher in 3, 2, 1. Let's go. Area of the cloth section. How do we do it? So, what are the few things I need to find? Alright, so again, we know what is 3, we know what is 5. Okay, so I'm just drawing out for you again. This is 3. No, there's no 5, sorry. What is 7? Why am I saying 5? 7. Again, how do we find? Alright, okay, seems like area is more of like this strong part for this class, yeah? Okay, I think this one should be alright based on the responses I have. Very good. Take note, be very, very careful. What is the area of the cloth section? Okay, we have the last few seconds. For those of you have to respond, please respond accordingly. Last 20 seconds. We are moving on, almost there. To my last. Alright, okay, let me see the response. Very good, most of you all got it right, which means you guys know that we have to take, in this case, the big sector. Take note, this is half times 7 squared times radian of the angle 2.5 equals to 61.25 minus the small sector, in this case POQ, which is half times 3 squared times 2.5, which is equals to 11.25. Lastly, to find the area of the cloth, we just, as mentioned, because it's a small, if we are only finding this one, big one minus the smaller fan over here, smaller section, to get the blue one. So in this case, cloth is just, why do I write cloth again? I need to write, okay, take note, proper writing is required. So the area of the cloth, 61.25 minus 11.25. That's where I get the area, which is 50 cm squared. Alright, with that, that is the end of the revision for today, and I hope you guys have revised what is required, mainly measuration, what is the different shapes that you need to be familiar with, the arc length, and the sector area. Alright, once again, thank you everyone for staying with me. This is Teacher Jason over here, and if you require any help, I'll be staying over for 5 minutes to stay with you. Until then, this is Teacher Jason signing off. Take care. Bye-bye.